Hi, welcome to Nomis Academy. In this video, we are going to solve problems under the application of differentiation. I consider it as a miscellaneous worked example. So let's take the first one. Example 1. Find the stationary points of the function f of x equal to 3x squared plus 3x plus 2. Alright, solution. So we are asked to find the stationary point of the function f of x equal to 3x squared plus 3x plus 2. Now, for a curve to have a stationary point, it means that at that point, the y ds or f prime of x is equal to 0. For stationary points, comma, then f prime of x is equal to 0. So we have f prime of x, so we have to differentiate the function, and that will equal 6x plus 3. So this is the derivative of the function, or the f prime of the function. Alright, at this point, we have this to equal 0, so we equate it to 0 to find our x. So x at this point will be, when you divide both sides by 6, x is equal to minus 1 over 2. So that is the value of x. Alright, so we are going to substitute this value in the function given. So f of minus 1 over 2 will be 3 into minus 1 over 2 squared plus 3 into minus 1 over 2 plus 2. So that will be 3 into 1 over 4 plus, minus, since we have minus times plus, we have minus 3 over 2 plus 2. Okay, then we have 3 all over 4 minus 3 all over 2 plus 1 over 1. The LCM is 4. So we have 3 minus 2, 6 plus 4. And that will finally give us minus 3 plus 4, which is 1 over 4. So at this point, we can now state that the stationary points occurs at when x is minus 1 over 2, y is 1 over 4. So this is the stationary point. Alright, the next example 2. Find the rate at which the area of a cycle is changing with respect to its radius when the radius is 5 centimeters. Okay, this is one of the WAEC questions. So let's solve this problem. It says find the rate at which the area of a cycle is changing with respect to its radius when the radius is 5 centimeters. The rate of change of area with radius. So that is actually the A over the R. That's the rate of change. Now, we know that area of a cycle is given as pi r squared. And now the rate of change of the area of the cycle is the A over the R. That is the rate of change or the rate of change of the area of the cycle with respect to the radius. Okay? When you differentiate this, you have 2 pi r. Alright. So now when the radius is 5 centimeter, the A all over the R is equal to 2 pi times R is 5. So we have our dA all over the R to be 10 pi. So this is the rate of change of area with radius. Alright? So this is the solution. Let's pick the next problem. The next problem is also a WAEC question, example 3. The distance s meters a particle covers in t seconds is given by s equal to 3 over 2t square minus 3t full stop. Find in meter per second square the acceleration of the particle. So this is also a WAEC question. Alright, solution. Now this is the equation given to us. They say the distance s meter a particle covers in t seconds is given by s equal to 3 over 2t squared minus 3t. Find in meters per second squared the acceleration of the particle. Now we know that acceleration is given as the square s all over the t squared. This is acceleration. Now since we have the function given to be s equal to 3 over 2t squared minus 3t, okay, we are going to differentiate this, and that will be the s over the t. So this will give us 6 over 2t squared. Okay, 6 over 2t minus 3. Okay, and that is 3t minus 3. Now to differentiate further, and that will give us the acceleration, which is the square s over the t squared is equal to, differentiate t minus 3. We have 3 minus 0. So this is it. And the unit, they say find in meter per second. So we just put meter per second squared. So this is the acceleration of the particle. Thank you for watching. See you next time. Bye.